Well, welcome everybody to the Virtual Planetarium for July 2024. I'm here as ever, with Paul Abel, and we're going to talk about what is visible in the July night sky. And we'll start with the inner solar system, as we always do, and Mercury. And on the 1st of July, Mercury is at magnitude minus 0.4 and set 70 minutes after the sun. Shining at mag minus 0.1 on the 7th of July, a 3% lit waxing crescent moon sits 2.2 degrees to the north. Reaching greatest eastern elongation just after mid-month, Mercury remains poorly placed on the 18th of July at magnitude plus 0.4. It sets an hour after the sun, and by the 31st of July, this reduces to 30 minutes. So we're probably not going to see Mercury at the end of the month, as it's only magnitude plus 1.1 as well. But don't get disheartened that the first planet is not so good, because the others are starting to get better. Having said that, Venus isn't so good, is it?
No, unfortunately, it's still in the evening sky, but it's very low down, so it's lost in the evening twilight. Magnitude minus 3.8, so pretty bright, but it sets 30 minutes after the sun on the 1st of July, but that's only increased to 40 minutes by the end of the July. So it's going to be a pretty tough object. But as we said last time, at the end of the year, Venus will be a very easy, prominent object in the evening sky. We're just waiting for it to pull ahead of the sun and take a few more months for that.
It's worth noting, though, Paul, that it does provide an opportunity to navigate to a less than 1% lit waxing crescent moon, which is 3.3 degrees to the northeast of Venus on the evening of the 6th. And that's a really thin crescent.
It does, if you can find Venus. It is a really thin crescent. Yes. And I guess the money is, which is easiest, the thin crescent or with Venus? Which is the toughest one of those? It's a difficult call.
It is.
Moving further out, though, the planet Mars is now becoming a viable morning object. On the 1st of July, it's magnitude plus 1.0, and it rises nearly 3 hours before the sun. There'll be a nice 25% lit waning crescent moon, 7 degrees to the west on that month. But the point is, Mars is now 3 hours is enough time to begin to observe it properly.
Yes.
By the end of July, Mars is rising just after midnight BST, so 0050 BST or 2350 UT. And its disk size the apparent diameter is starting to increase now. So 8-inch telescopes should be able to show some detail on the disk, particularly with the dark markings like Syrtis Major. So I would advise people to start observing Mars now.
It's also worth pointing out again that there's a 29% lit waning crescent moon 5.6 degrees northwest of Mars and 2.1 degrees east-southeast of the Pleiades at the end of the month. That's on around midnight on the 29th into the morning of the 30th. And that is indicative of a very interesting display, which will also incorporate the next planet out, which is Jupiter. And morning planet Jupiter rises around 3 o'clock BST at the start of the month, when it can be seen amongst the stars of Taurus, not too far from the Pleiades I've just mentioned. However, the short nights will work against the planet at the start of July, but it's at the end where things get really exciting, because you'll see the waning crescent moon moving through the constellation, and you'll have Jupiter there, which is pretty bright, and Mars and Uranus as well. So it's as we go into darker territory, in the morning sky at least, you should get a beautiful view of these 3 planets amongst the stars of Taurus. And I'm really looking forward to that, actually.
Yeah, it'd be nice to have all these planets coming back. And Jupiter is such a rewarding planet through telescopes. Even small telescopes will reveal the 2 main equatorial belts and the 4 major satellites. And larger telescopes, when you get good seeing, the detail in Jupiter's cloud tops is quite overwhelming. So
yes, it is.
I'm looking forward to having these planets back in our evening skies. Further out, planet Saturn is struggling in the morning sky at the start of July, but it is improving by the end of the month.
Yes.
Shortly after rising late in the evening on the 24th of July, We also have a nice 83% lit waning gibbous moon sitting just 1.3 degrees east of Saturn. And by the end of July, 31st of July, Saturn appears at its highest altitude of 30 degrees due south under deep twilight. And you'll notice something quite interesting about Saturn this year. The rings are now really starting to close up. They're really, really narrow. And the reason for this is because we're starting, as of next year, we'll be passing through the ring plane, and Saturn's rings will appear edge on and will vanish in small telescopes.
Will. Yeah.
And this is quite something to see before then.
There's also another thing which happens, which we'll probably start mentioning next month, actually, as Saturn gets into a better position. But there will be interactions between the brighter moons of Saturn and the planet's disk itself. You get the Galilean shadow transits and transits of the Galilean moons with Jupiter. Well, similar thing will happen with Saturn's moons. And the one which is really exciting for me, which I feel shortchanged on, is Titan. Because the last time we had a ring plane crossing, I remember getting excited for seeing Titan's shadow moving across the planet and Titan moving across the planet as well. And from the UK, the timings were all wrong. The way the orbital period of Titan meant that every time it was doing that, it was just the wrong time of day. But as we go into the end of 2024 and into 2025, it's the right time to see them. So that's really exciting, and I'm looking forward to actually seeing some events involving Titan with Saturn. That's going to be fantastic to look for.
It is. I echo your disappointment. I have never seen a transit of Titan, so it's definitely on my to-do list, and hopefully, everything crossed, we will get to see it at least this year or next. So that'll be a good thing to look out for.
Absolutely.
Moving on, Uranus, magnitude 5.8. So technically naked eye visibility, but not in a twilight sky. Uranus is in the dawn twilight and not really a viable target. Same doing for Neptune, really. Neptune's position proves during July. It gets to an altitude around 30 degrees with the end of the month, but both planets I think are going to be a bit difficult at the moment.
It's worth mentioning, actually, with Uranus, to look for it 39 arc minutes from Mag plus 0.9 Mars on the 15th of July. So that's actually pretty close, those two planets. I mean, it won't be in a position where you can observe it properly, but you will be able to see it as a dot next to Mars. And of course, Uranus has a distinctly greenish hue to it, and Mars has a distinctly orange hue or salmon pink hue to it. So it'll be an interesting colour contrast between those two planets.
Yes, and even in a small telescope, that's quite a noticeable thing. So the colours are very, very, very striking.
Yes, they are. Okay, well, let's have a look at some of the special events which are happening this month, and we'll start off by reiterating what we said last month about we're in the summer months now in the Northern Hemisphere, so July is the second main month for Noctilucent cloud spotting. Don't know how it went last month because we're recording this before that would have started, but we had poor Noctilucent cloud viewing in 2023. There weren't many displays to speak of, so it'll be interesting to see how we fare in 2024. Is it something to do with the solar activity cycle, for example? If we get a massive display in 2024, that'll blow that out of the water. But that's the importance of doing observations. So any clear night you've got, if you go outside, have a look for Noctilucent clouds. If you don't know what they are or where to see them, well, they typically are seen low down over the northwestern horizon, 90 to 120 minutes after the sun has set, or low above the northeastern horizon a similar time before sunrise. And if you get a really bright display, then it'll start off in the north, low above the northwest horizon, and then track round through north and end in the northeast. I've seen a few of those, and they're quite spectacular when they do occur.
They are. We had a very good display a couple of years ago, didn't we, in Leicester? And they started off in the west in the evening.
That was really weird, yes.
It's unusual. I've never seen that before. But they really were quite striking. And you could see them changing over 5-10 minutes. You could see the structure in them evolving.
Yeah, but that's another important thing to mention, actually, that what they look like. You think clouds? Are clouds really that interesting. We know what clouds look like. We see them all the time. But these are special clouds. They're seeded by meteor dust. So as a meteor vaporizes in the atmosphere, the dust it leaves behind acts as a seeding agent for tiny ice crystals to form. So these are ice sheet clouds. And from the ground, they're so high up, they're an altitude of about 82 kilometers, that even though it's dark for us on the ground, they still catch the sun's light. So they appear to shine at night, which is where they get the name from, Noctilucent, meaning night shining. And they have this sort of eerie electric blue, it's often described, colour. It's quite a weak blue, actually. It's sort of whitish blue hue to them. And they have a distinctly structured appearance, like herringbone structures. Fine meshes are fairly common in Noctilucent cloud displays.
Yeah, they're quite distinctive. People always say, "Oh, I'm not sure if I'll be able to recognise them," but you will. When you see them, you know what they are.
You need to make sure you have a flat horizon in the direction they're occurring. I've had, actually, in the past, I've seen them and I've put out alerts on social media and people come back and say, "Oh, I can't see them." And it's because you haven't got a flat enough horizon. No. They are low down quite a lot of the time. Sometimes they do get high. I've seen them go over towards the south in the morning as the sun is getting higher. They sort of begin to, or catch more light, head overhead, and I have seen them edging towards the southeast, and then they just disappear. As the sun gets to a certain level, the sky gets bright enough, and they just disappear instantly. They've gone. But they are fascinating to watch. They're fascinating to record, and get out there and look for them. If you get a really bright display, actually, if you've got a phone which is capable of taking low light pictures, as a lot of modern camera phones are, or smartphones are, their Noctilucent clouds make a very good target because phones can pick them up.
Yeah, so it's worth keeping an eye out, and as we've said, we don't know how the season will be, but hopefully we'll get some nice displays. Okay, on the 5th of this month, Earth is at its furthest point from the Sun. This is known as aphelion, and on the 6th of July, dwarf planet Ceres reaches opposition. It's magnitude 7.3, so that's an easy binocular target, and it's passing through the stars of the handle of the teapot asterism in Sagittarius, the Archer.
Yes, that's good. On the 17th, if you can get a view of Jupiter in the morning sky, there's a double shadow transit occurring, which involves the shadows of Io and Europa, which will be crossing the planet's disk between 0206 and 0231 BST. Those are the times, by the way, when both shadows are on the disk. So if you want to see the double shadow transit, sometime between 0206 and 0231 BST.
On the 23rd, dwarf planet Pluto reaches opposition, shine at magnitude plus 14.4 in Capricorn. That's quite faint. You really will need a large telescope to see that visually. I'm not sure actually. No. Will that be visible in my 12-inch telescope? I'm not sure, but
Pluto's an interesting one, you know. There have been lots of claims of it being seen in much smaller instruments, I think down to as small as an 8-inch under really dark skies. It is, magnitude plus 14.4 on paper is very faint, but a modern camera will pick it up without any problem. And if you are lucky enough to own the new fad with smart telescopes, that'll pick it up easily.
That's true, actually.
If you have something like what are those? There's the Dwarf 2 and there's the C-Star. C-Star's a 50mm telescope, 2 inches, and it'll pick Pluto up really easily.
That's true.
That's a good way to catch it.
It is. I was thinking of my more old-fashioned method of turning the telescope to the object and looking through the eyepiece. I know it's been many centuries. I know it's been many centuries since you've attempted that, Pete, but it is still my tried and trusted method. And I actually don't know. I've not actually pointed my 12-inch telescope at Pluto to see, and I will have to give this a go. So
it's an interesting thing to go for, and well, I
wonder whether if the variation. I wonder if there is firstly some variation in brightness of Pluto. We know its surface surface is partly dark, partly bright. And also, it isn't a point source like stars. It's a disk, isn't it?
That's it. As I was just about to say that, yeah. But it's quite low down, so it needs to, well, Capricorn it's starting to get higher, isn't it? But it's not the highest point in the sky. But it's, if you get a clear night and you've got really dark skies, go for it and see if you can find it. You should be able to locate the area where Pluto is in, and just either do a sketch with your telescope of the stars around. There'd be quite a lot of stars around there,
Yes.
down to that magnitude, or take a photograph. And if you take a photograph over several nights, then compare them, align them, and then blink between them. And if you see a dot moving, you may have caught it.
Yeah, so definitely worth doing. On the 24th, another double shadow transit on Jupiter, again with Io and Europa, this time visible between 0401 and 0510 BST, so that's 0301 and 0410 Universal Time.
On the 30th, as we mentioned earlier, there's a 29% lit waning crescent moon, which rises, well, as it rises, it will be 1.5 degrees east-southeast of the Pleiades. That's always rather a lovely sight, actually. I do like that. And then we have the waning crescent moon again, beginning its passage through the wonderful celestial real estate, which is involving Taurus and the clusters in Taurus, the Pleiades and the Hyades, and of course Mars, Jupiter and Uranus.
So plenty of nice special events to look out for. In the night sky then, well, there's also plenty to see here in general. So the Northern Hemisphere summer is once again, fingers crossed, clearer than we had at the start of the year. And July is actually filled with all sorts of local deep sky spectacular objects. And this is because the Milky Way, one of the spiral arms of the galaxy in which we live, arches high overhead in the summer sky.
Yeah.
And now I can see the Milky Way from my garden, but I know it's much better from yours, Pete. And if you could go out to a darker sky, the Milky Way, the summer Milky Way passing overhead is breathtaking, simply because the amount of structure you can see in it with the naked eye. It's certainly not just a sort of faint fuzzy line passing through as it appears in the skies from a town or a city. It has darker regions, there are regions of interest, and you can see it's a highly structured object. It really is worth going out to a dark sky just to see it.
I completely agree with that. It's, it's one of those things that it's interesting, isn't it, with astronomy? Sometimes during the day you might think, well, that's a good idea. I'm going to go out there and I'm going to have a look for the Milky Way. And you get a nice clear night. And then as the evening rolls on and you're feeling a little bit weary from whatever you've been doing throughout the day, you think, oh, maybe I'll do it another day. Don't. Actually, if you've got the means, go out and have a look. You will be, if you can find a place which is really, really dark, you will be rewarded by a beautiful sight, because it is quite spectacular, the summer Milky Way. As it passes through Cygnus, that's where the brightest region of it is for us in the UK. That's not how it should be. It should actually be the bit which passes through Sagittarius,
Yes.
which is the core direction of the Milky Way. But because that's so low down for us in the UK, we get atmospheric attenuation, which tends to reduce the impact of the core. But the bit going through Cygnus is quite beautiful.
It is, and it's always good fun to take a pair of binoculars and just scan down this, because you can see the Cygnus rift, this darker structure which is caused by dust obscuring the starlight, and you've got all manner of open clusters and objects in Cygnus. And if you follow the binoculars all the way down, all the way down along the Milky Way, it really is quite an astonishing sight.
Yes, it is. I mean, there are some fantastic objects down towards Sagittarius, which are probably, I think we'll leave those for a bit later on, because we need the skies to get a little bit darker, really. As we're getting into July, we get all enthusiastic because the skies are getting darker. But actually, it's probably August and September where you get the best views of the Milky Way if the skies are clear, because then the night has got dark enough to and the Milky Way is in a position which is quite favourable. So that's a good time to go out. We should mention, of course, that as we are in summer, that we've got a giant triangle in the sky, which is the summer triangle. Always sounds a bit crazy, that, because if you've got any three stars, they're going to make a triangle. But the summer triangle is quite distinctive. In fact, I can remember pointing out back in the winter, when we did have a clear sky, the winter triangle to somebody, and just thinking as I was looking at it, that even though it's made up of in fact, it's made up of the brightest nighttime star of them all, it's got Ceres in it, it just doesn't hold any stance against the summer one. The summer one, for some reason, I don't know whether it's the dimensions, the proportions of the triangle, it just seems to stand out better. Actually, having said that, I think I might have answered that in my own head. The reason for that is going to be because the sky is bright, so the three stars stand out better, don't they?
They do. They also, in my opinion, this is going to sound really absurd, but they form a nicer triangle.
Yes, it does.
It is a really good, sharp triangle. Not quite right-angled, but still nonetheless a very nice triangle. And as you say...
It's an isosceles, isn't it? It's a classic isosceles triangle.
It's really quite striking. And of course, we should mention, it's made up of three bright stars, Vega, Deneb and Altair. Vega is the brightest in the constellation of Lyra. And the great thing about Lyra is it's not a particularly large, it's not a large constellation at all, or particularly bright, but it is very distinctive because it's made of this little diamond of stars, which has some interesting objects in it.
Yes, you're quite right there, because that little diamond, I always refer to it as a squash diamond because it's not quite symmetrical, hangs to the south of it, but it is interesting. It has got some interesting objects in there. But just before you go down into that, it's worth noting that if you go to the star Vega, and then you look at the star which is at the upper or the northwest corner of that squash diamond. So those two stars, Vega and that star. And then there's another one which makes an equilateral triangle, which is further to the north. And that one is Epsilon Lyrae, which is a star that if you've got really good eyesight and you look at it, you can split it into two. And if you have a telescope and you look at it, you can easily split it into two. And if it's a reasonable night and you've got good optics with your telescope, you might even be able to split each of those two stars into pairs again, because this is the famous double-double.
It is quite you do need a bit of magnification to do that, actually.
You do.
But once you've got it, it is quite a striking sight in the telescope. The two double and then the two of themselves again double. They're quite the separation of the two pairs is actually quite small. What is it? Something like 2.8 arc seconds and 2.2 arc seconds. So you probably need a reasonable, about 150 times magnification to be able to see it.
Yeah, and the main pair are 3.5 arc minutes apart, which is the human eye can theoretically resolve, I think it's about an arc minute. So it's quite easy to see them split, the main pair, with the naked eye. If you just take your time, look at it. One of the big problems, actually, is it's really high up in the sky, which is an awkward place to look. So the best thing to do is to lay back on a sun lounger or something and just look up at that star, relax, and you'll see it split into two if you've got good eyes.
Yeah, that's a good way to do it. Roughly midway between the bottom two stars in Lyra, we have a wonderful object called the Ring Nebula, M57, which looks like, in a small telescope, it looks like a little Cheerio. Other breakfast cereals are available, but it's quite a distinctive shape. And it actually doesn't take you don't need a massive telescope to be able to tell it's sort of this glowing, dusky ring with a darker core. It's still one of my favourite deep sky objects because it's very easy to find and it doesn't need a lot of power to bring it out to be obviously a deep sky object.
Many, many years ago, I built my own telescope. It was an 8 3/4 inch reflecting telescope.
Is this the one that looked like a lobster crate?
You were very disrespectful on a sky night with that. It was built. It was built to military standards, basically, because I ground the mirror myself, and I was quite young when I did it, and ordered a book from the library to help me understand how to grind the mirror, and I was very impatient. I was really excited, and I knew the basics of what to do, and of course you didn't have the internet back then, so I basically thought I can start it, and I started to do it. And when I eventually got the book, I checked the focal length of the mirror, and it was about something like about 24 inches. It was 8 3/4. So it was quite a fast mirror, which isn't what it was supposed to be. And I can remember telling Patrick, and he was very sympathetic, and he said, "Oh, you've ground a vase." Thanks, Patrick. So, but basically, the frame of the telescope was built from whatever I could get my hands on, and I had a neighbour who he was getting rid of some galvanised grid fencing. So I took this and cut it up into shape, and my dad kindly welded it all together for me. And it was military standard. You could do anything to this telescope and it would hold its ground. But I think the Ring Nebula was the first thing I ever looked at through it. And I can remember using a low power eyepiece and thinking, oh, I can't see it at all. And that's actually correct, because it looks like a star at low magnification. And what you have to do is you have to sort of work out where you think it's going to be, center up on a star, and then put in a higher power eyepiece, a medium power eyepiece or a high power eyepiece. And if you've got the right area, you'll see this rather beautiful little oval glow. And it's spectacular, isn't it?
It is a lovely sight. We had some good skies last summer, and I had another look at it, and I don't know. I've seen so many pictures of the Ring Nebula, so it's possible it was in my head. But I thought I could see a slight yellowish tint to it. It was so, yeah. But it was still a remarkable object to see, and to think that this is really the aftermath, the dying embers of a star that's shed off its layers into outer space, and this is really all that's left, is quite a sobering thought. And one day, our own sun will be a ring nebula in somebody's sky when it reaches the end of its life. So
yes, it will.
This type of planetary nebula is all part of stellar evolution, but lovely objects to look for.
But there's another really lovely one, isn't there? If you go from the star, which is in the lower left corner, so that's the southeast corner of the squashed diamond underneath Vega, that's Gamma Lyrae, and you extend the line from that through Albario and extend it for the same distance again, you'll arrive at M27, which is the Dumbbell Nebula, which is actually, I think, in its own way, it's as spectacular, if not more, than M57. It doesn't look like, whereas M57, if you use a bigger telescope, you'll see it's an oval shape with a darker region in the center, which is the hole. But with M27, it looks a bit like an apple core, so it's filled in the middle. But you can see it with binoculars really easily, and it's quite large.
It is quite large, and it is, as you say, it doesn't take much telescope power to be able to see the apple core structure of it. The interesting thing is that if you use larger telescopes on it, they don't seem to show that much more.
No.
I think you need a very dark sky and a huge telescope to be able to see more detail in. But of course, I imagine, again, the Sea Star and other telescopes will bring out some nice details in it.
There'll be thousands of photographs of it. Okay, well, we're showing that as the nights are getting darker, we're seeing more objects and we're getting excited about the Milky Way. So I think we'll probably end at this point and just say we hope we get some lovely clear skies. Look out for those planets at the end of the month in the morning sky, and just enjoy whatever you see up there. So thank you very much, Paul.
Thanks, Pete.